Okay. Yeah, hi Purva. Have you started with the Verilog or digital electronics?
I started with the VLSI session 1.
Okay. Have you understood what is the
Yes, yes.
difference between Verilog, VHDL, and how to write the syntax
Yes, I've
descriptions?
understood.
Okay. Okay. What about Grar and Sai Prakash? Pranay, Pravina, have you completed operators till operators? Ramya, Abdul.
Yes, Prashanti.
Okay, what about Pravina?
Yes, ma'am. I also completed till operators.
Okay. Ramya?
Yes, ma'am. I'm also completed.
Okay. So, everyone understood? Uh, First is the arithmetic operators, right? You know what is mean by plus. We do the addition, minus, multiplication, division, modulo, and power. Okay. And relational operator less than, greater than. Check the comparison between less than, equal to, greater than, equal to. And coming to equality operator. So, what is the difference between arithmetic equality and normal equality operator? What is the difference between arithmetic equality and normal equality operator? Hmm?
It also compares total.
What?
Like arithmetic equality operators, like I think it's for the mathematical operation, man.
Hmm. Okay, let me give some examples. Suppose A equal to 1 0 1 1 x. So doing arithmetic equality operator. So both are equal or not?
No,
Not equal. Okay. Suppose 1 0 1 1 1 0 1 x. Both are equal or not?
no, Prashanti.
1 0 1 z 1 0 1 x. Both are equal or not?
No. In this operator, so it will compare the bit to bit. So if it is the exact bit is there, so then it logic tends to one. Otherwise, it will be zero.
Okay. What is the difference between three equal tos and two equal tos?
It also compares X and Z.
So by using three equal tos, we can compare with the x and the z. So unknown and high impedance values can be compared. By using two equal to operators, we can compare with the 0 and the 1 only. So if we want to check with the x and z values, we need to use arithmetic equality operator, whether it is equal to or not equal to. Okay. So that is the difference. So here there are different examples. I already told you to do the simulation, right? Next, logical operators. So did you all understood A into B for 0 into 1, x into 1, z into 1, 0 plus 1, x plus 1, z plus 1, 1 plus 1. Like that not operation. Okay, did you try Pravina and Ramya? Karar, Pranay. Hello.
Yes, ma'am.
No, ma'am, I'll try today.
Okay. Next, bitwise operators. Bitwise operators also we already discussed, right? And shift operators we discussed, and reduction operators also, and concatenation operators also. I will give you example. Just let me know what is the answer. Suppose A is equal to 4-bit binary 1010, B equal to, so concatenation operation out is equal to A of down to 0, comma B of 2, comma C, comma tick B 1 1. So what is the output here for this concatenation operator? What is the output? Concatenation means combining the values. Okay. So Purva or new joiners, can anyone answer? Just combining the values. Okay. Sai Prakash and Navjot. Can you answer what is the output here? We just need to combine A of 1 down to 0. A is equal to 4 tick B 1010. That means binary value representation in Verilog. 4-bit binary value representation. B equal to 1011, C equal to 00. So here in out we are mentioning A of 1 down to 0. That means 1 down to 0, particularly first bit and second 0th location bit, and B of 2, B of second location, C comma 2 tick binary 1 1. That means 2-bit representation, binary representation. Okay. So what is the output now?
Ma'am, it's 10000111.
1 0 0 1 2.
0,
Okay.
another 0,
Okay.
1 1.
1 1. Okay. So this is the concatenation operator. So A of 1 down to 0. So 1 down to 0 is this 0 1 2 3 4 locations. B of 2. B of 2 means this bit, and C. C is entire whatever the bits are there, like 4 bits or 5 bits, whatever we need to combine all, and 2-bit binary 1 1. So we need to mention 1 1. Okay. Suppose replication operator.
Prashanti, so I have one doubt here. So for 0, we have, for C value, we mentioned 00, right?
Mm.
So by default, we didn't mention any type of bit. So by default, it will come as 32-bit, right? So
By
32 zeros will
default,
come.
it is 32-bit, but I didn't mention here 4-bit. Suppose 4-bit and 2-bit.
Yeah, if it is mentioned, it's okay. If it's not mentioned, means it will come as the output at 32-bit, right?
It depends on your data type, what you will mention. If you mention reg data type, based on how much size you are mentioning for reg, that much of size it will print. If it is integer, 32-bit, or if it is any other bit type, based on that size, it will print.
Okay.
Yeah. Next, we will try according to your doubt. We'll try that example also. And next, replication operator. Suppose same example. So replication is nothing but repeating n number of times. Okay. Now tell me the answer. What will be the answer here? Just repeating number of times. So 3 times A, 5 times CD. What is the output? Travina, what is the output here?
10 will be repeated 3 times, ma'am.
Okay.
B as it is, we can written as a 00. Sorry. Yes, ma'am, 00.
Only 0. Okay.
After that, C is repeated as a 5 times. 0 will be repeated as a 5 times.
Mm-hmm. Okay.
D also repeated as an 5 times. After that, 1 ma'am.
Okay. Is that correct?
No, ma'am.
Maybe
Ma'am, first C comma D will be concatenation. After that, we have to multiply with 5.
Mm. Okay. So first we need to combine C, D. If you observe here, C, D are in one concatenation. So first we need to combine C, D and then need to repeat 5 number of times. So combined it is repeating 5 number of times. Okay. So what is the value of C? 0, 0. What is the value of D? 1, 0, 1. So that is 1 time. Again, 5 times it will repeat same value. Okay. And then next, what is the value? 1, 1. Okay. So this is the difference between concatenation operation and replication operator. Okay. Any doubts still here?
Ma'am, where do we use this concatenation and repetition?
Um, Mostly, suppose we write the full adder code. Okay, in the full adder code, whenever we are assigning some comma carry, the result we can assign some to carry. Suppose in the full adder there will be 3-bit 0 0
Mhm.
0 1 0 or 0 double 1. Okay, so what is the output of 0 double 1? 1 will be the carry, 0 will be the sum.
Mhm.
So while we are writing the program, we will put sum comma carry equal to a plus b plus c. So this is a simple logic, one line implementation code for full adder. Normally we have seen behavioral model, data flow model, gate level model, structural leveling, right? Lots of code
Mhm.
will be there. But to write a single line, we can use this simple logic. Okay. So
Okay. Okay.
automatically when we do a plus b plus c, this
Mhm.
this will be assigned to sum and this will be assigned to carry. So I have written reverse. So here
Mhm.
carry and here
Yeah.
sum. So this
Okay.
0 will be assigned to sum and this 1 will be assigned to carry. Like that in test cases also we can assign different values like that. Okay.
Okay. Okay.
Yeah, for multiplexer also we can do. Okay.
Okay. Okay.
Next example. Okay, next operator, conditional operator. So conditional operator also called as ternary operator. So for conditional operator, what is the operation like? What is the syntax? First, we need to write the condition. That means expression, any expression. So if the expression is true, true statement will be executed. If expression is false, false statement will be executed. False statement. Okay. So based on that, we use the conditional operator. Suppose condition. I'm taking condition like suppose A is equal to B. A is equal to 10. B is equal to 20. I'm taking a condition A must be greater than B. If it is a true statement will be executed, else false statement will be executed. Okay, now what is the output? What is the output? See, condition expression. If true expression will be executed. If false statement will be executed. So here what is the output?
10.
So if A is okay, go ahead.
10, ma'am.
10. Okay, so here A is greater than B. So it is false. So false means this statement will be executed, B minus A. So output is 10. Okay, like that if A is less than B. So A is less than B is a true. So true statement will be executed, A plus B. Then output will be 30. Okay, like that most of the cases like multiplexer we can write in a conditional operator, and encoders, decoders we can write using the conditional operator. So there are a lot of cases. So while we are writing different test designs, then you can find. Okay, so everyone understood all the operators. If anyone new joiners are there, I will be sharing the recorded session, so you can go through the recorded sessions. Still, just 2 sessions are completed before. Okay, and any doubts still here?
No, ma'am.
Okay, so today we are going to discuss very important topic. Okay, so just take pen and paper, book. I told you to keep some book, right, to note down all important points from Verilog system, Verilog UVM, like that. So just take pen and book. Before session also I told same topic to for some students, but when I asked the questions in the end of the session, they didn't answer and they didn't return. Okay, so don't do like that. Just take the notes and write down the points. So coming to the Verilog description styles, so we have 2 description styles in Verilog. So basically, before we already seen how to write the program in Verilog by using the behavioral modeling and data flow modeling. Okay, so while we are writing the program, we need to follow some rules because for behavioral we use the always block. So whenever we are using always block, what are the rules we need to follow? Whenever we write the data flow, what rules we need to follow? Okay, so can you tell me what is the difference between behavioral model and data flow model?
Behavior model is using truth table.
Mm. Okay, so here for 4 by 1 multiplexer, we are writing the program by using the truth table. So if we write the program using truth table, that is a behavioral model. So if you observe the program here, this is a behavioral module, marks, inputs, declaration, input, output, declaration. Here we are using always at the rate of, and within the case statement, multiple inputs mentioning with the output. So that is a behavioral model. If we write the program using the output expression, that is a data flow model. So declaration wise everything is same, but only functionality wise we change. Right here we use the assign block. So while we are using assign block, we need to follow some rules. While we are using always block, we need to follow some rules. Okay, so now we will see those things, so that you will get the clarity how to write the program in Verilog. Okay, so coming to the description styles in Verilog. Okay, first is continuous assignment. So data flow. Data flow means what?
So either top to bottom or bottom to top.
Top to bottom or top bottom to up? Why do we need to follow any flow here? I mean, execution wise. In Verilog, every code will be executed from top to bottom only, not bottom to up. Okay, so data
Okay.
flow in the sense assign statement. So we write the program using the assign statement, right? So whenever we write using the assign statement, that thing that format is nothing but data flow modeling. Okay, so assign is nothing but we call it as a continuous assignment statements. Continuous assignment statements. Okay, so while we are writing continuous assignment statement, we need to follow the rules. Like what are the rules? LHS side variables must be declared with wire data type. We have two types of data types in system Verilog. One is a netted data type, other one is a registered data type. In netted data type, we have classification like wire, W or W and. In registered data type, integer, time, real, reg data type. Okay. So LHS side variables must be declared as a wire data type, or HS side variables must be declared as a wire data type or reg data type. Okay, suppose I am writing example assign out is equal to, or assign sum is equal to a XOR b for half adder. Okay, assign carry is equal to a and b for AND gate. Okay, so here what are LHS, what are RHS? Some will be LHS. So LHS variable must be declared as a wire data type. Okay, while we are declaring input output, we mention input output, right? So there we need to mention as a wire data type. Okay, so some must be LHS side, some must be wire. A and B or RHS side. That means A and B must be declared as a wire or reg data type. So here same, we mention carry as a LHS and AB or HS. Okay, so these are the rules we need to follow. Continuous assignment. Mostly, what is the difference between wire and reg? Wire doesn't store the data, reg store the data. So wire doesn't store the data means mostly we use for combinational logic circuits. Okay. Reg store the data mostly we use for sequential logic circuits. Okay. Next, next one is behavioral modeling. Behavioral modeling. So behavioral modeling is nothing but in that we use procedural assignment statements. In behavioral modeling, we use procedural assignment statements. Another thing is assign is a synthesizable. Assign is a synthesizable. Synthesizable means what? We can use in the design, only in the design, not in the test bench. Okay. So in the behavioral modeling, we have two types of procedural assignment statements. One is always block. Another one is initial block. One is always, another one is initial block. So always block uh, is used in design, which is a synthesizable, and also non-synthesizable, both in design and test bench. We use in design plus test bench. Okay. Whereas initial block we use only in the test bench, which is non-synthesizable. Okay, initial block is non-synthesizable. We can use only in the test bench. Okay. Next, always block is repeated loop. Repeated loop, and until we terminate the block, stop the execution. Stop the execution or it stopped running. Okay. Initial block is one time execution. One time execution. It is not a loop. One time execution. All initial blocks will start at a zero simulation time. Zero simulation time. So that is the difference between initial block and the always block. Okay. So whatever the statements we are writing within the initial block or always block, LHS side variables must be declared with either declared with a reg data type only. LHS side variables must be declared with reg data type. RHS side variables must be declared with either reg data type or wire data type. Okay. So in the data flow modeling, LHS side variables must be declared with a wire. In procedural assignments like always or initial, LHS side variables must be declared as reg data type. And mostly these are used for modeling the sequential logic circuits. Sequential logic circuits. Okay. And within the always block we use blocking assignments, non-blocking assignments, fork joins, parallel execution statements, serial execution statements, all those things we will discuss in the coming sessions one by one. So this is what the difference between data flow model and a behavioral model, and what are the rules we need to follow while writing the program. Okay, everyone noted?
Yes, ma'am.
Okay. So if you have any doubts, let me know. So here are the theory, whatever I explained, the same theory mentioned here. Data flow modeling. So what is meant by continuous assignment, assign statement? So assign C is equal to A plus B, or any expressions. Mostly it generates combinational logic circuit. Why? Because in expressions, the variables doesn't depend on clock or reset, right? So mostly those are combinational logic circuits. Okay, so assign C equal to B some expression, assign Z is equal to Y of 10. Okay, that's why LHS side variables must be declared with a net. The expression on the right hand side, which may consist of net or register data type, almost exclusively used to model the combinational logic circuit. We shall also see some examples of modeling sequential logic circuits using assign. Okay, like sometimes we design flip-flops or latches by using expressions, right? Those things we can design using sequential. Okay, so we'll see how to design different combinational logic circuits by using the assign statement. Okay. Already multiplexer we have implemented in a different styles, like a behavioral modeling, data flow modeling in switch level, gate level. We already implemented, right? So these are somewhat different ways how logically we can implement a simple multiplexer. Okay. Can anyone explain this code here? This first example code. Can anyone explain what's happening here? It's a 4 by 1 multiplexer and how the logic is going to implement here. Purva, can you explain? Or anyone?
Yeah, I guess I might be wrong. It's like we are giving 4 bits of data and one bit of data. I guess 2 bits, and we're assigning like the data to the input, the 4-bit data as the 2-bit data.
Okay.
I think that since multiplexer, this is 4:1 multiplexer, so there are 4 inputs of data lines, and there is 2 select lines. So the assign output statement means that the data part is being able to uh, be selected by the select lines on basis of truth table. Like if select line is 0, 0, so we will have the first input of data line. If 0, 1, then second input of data line, like this.
Mm. Okay. So what is the advantage of this type of implementation compared to before, whatever the codes we have seen?
It
Less number
makes
of lines.
less number of lines, code is compact, better optimization.
Okay. So how can we use the same code for 32 by 1 marks or 16 by 1 marks?
We can instantiate this module 4:1 into 16:1, like, or we
Mm.
can change the inputs. For 16:1, we need 16 data lines and 4 select lines, like that.
Okay. Okay. So you already seen behavioral model by using if else statement and case statements, right? Data flow modeling also. But this is a simple program which we can write in an optimized way. So here what is happening by using a single statement, by using the assign block, we are writing a out is equal to data of select. Okay, so this select line always change from the test bench. Okay, if selection line is a 0, so automatically data of 0 will be assigned to the out. If selection line is 1, data of 1 will be assigned to out. If selection line is 2, data of 2. If selection line is 3, data of 3 is assigned to out easily. Even if you take 32/1 multiplexer also, there will be 32 inputs and 5 selection lines. You can change all these 32 inputs by using a single line. But if you write a behavioral modeling, we need to write a lot of statements, lot of case statements, if else statements, or data flow modeling, we need to write very complex expression. So whenever the size is increasing, the complexity is increasing, right? So this is one type of array model for multiplexer implementation. Like that, before I have shown you full adder, right? How we can write for full adder by using concatenation operator. Simply we can mention sum carry comma sum is equal to a plus b plus c. But if you want to write using behavioral modeling, what we need to write for 8 combinations, for 0, 0, 0, 0, 0, 1, 0, 1, 0, for all combinations we need to mention case statements or if else statements. Okay, so without writing that much of logic, we can simply put this logic. Okay, so this is one type of multiplexer by using assign statement. Okay, we do the simulation, you can understand. Okay, see here, example, design and test bench. So in the design module, data select out is written and assign out equal to data of selector. So in the test bench, we written the test bench. I already explained you, right, how to write the test bench. We need to write module, test bench name, and inputs, outputs must be declared here. And here interfacing our design with the test bench, because design need to understand from which test bench we are writing the we are generating the test stimulus. So we need to interface this test bench and the design. So for that purpose, we are writing the DUT here. We need to mention the name of the design here. Example is the name of the design. DUT is the name of the instance, for example. And we need to mention the port list here. Okay. And within the initial begin, we are generating different inputs. Okay. So this is how we can write the simple test bench. So now my question is, I already told you all the inputs must be declared with the reg data type here, and all the outputs must be declared with the wire data type. Why?
Using assign statement.
What using assign statement?
Since it is a test bench.
Test bench.
Okay.
For test bench, we used to only always behavioral model, right? So that's why.
Mhm. Okay, so here we didn't mention any input data type, right? Before I told whenever we use assign, we need to mention LHS side variable as a wire data type. So here I didn't use any wire. That means by default, without mentioning also, by default these all are wire data type. So particularly if you want to mention as a reg, then we need to write as a reg like this. So whenever we use procedural assignment statement, like always in the design, which is always is synthesizable, right, as we written in the behavioral modeling, that time we need to mention output as a reg data type. Then otherwise no need to mention. Okay, so here my question is, why we used reg data type for inputs and var data type for output?
As reg data type stores something, and in test bench we don't know the output. Like, so we cannot make output as a register because output will change on the basis of DUT.
Okay.
So We cannot use output as reg data type because test bench are driven by this module we created in our code, and I don't store any value during simulation.
Then we can mention inputs as wire also, right? All the signals as wire. Hmm?
But
See, why? Because here initial block is a procedural assignment statement, right? So in the procedural assignment statement, I think you already noted those points. I told you to note down the points. Can you read that? What are the rules we need to follow when we write the initial block procedural assignment statement? Everyone.
So for initial block, it is one-time execution. And the
Hmm.
simulation time starts at 0 time
Hmm.
units.
Under
Enter
procedural assignment. What are the rules for LHS side variable and RHS side variable?
LHS must be register.
Okay. So here within the initial block, whatever we written data, select, here data and select are LHS side variables, right? So that's why any time in any test bench, for all the inputs we apply the stimulus. That means we assign the input values like that: data equal to something, select equal to something, address equal to something, write address, read address, like that. For every variables we mention some value. So all those variables we declare at the left hand side variables. Okay, so that's why whatever we are mentioning LHS side variables within the procedural assignment, like initial block, we declare as a reg data type. That's why in Verilog, all the inputs must be declared as a reg data type. All the outputs must be declared as a wire data type. That is rule number 1. Okay, in test bench you need to follow. But if you go with system Verilog, there we don't have any confusion like this. Even we don't need to follow where we are using the procedural assignment and where we are using continuous assignment. Every time we no need to check for reg or wire data type in system Verilog. There we have the logic data type. Instead of reg and wire, we can use directly a logic data type. Okay, but in Verilog we have this thing. Okay, so just run. Everyone understood how to write the test bench? Sai Prakash, Emmanuel. Okay, see here. Data equal to 1010. Okay. So selection lines will be changing. So at 0 simulation time, selection line equal to 00, and next 5 time units. Here hash 5 is the next 5 time units. Okay. So within the initial block, we will write all different inputs. You already know what is a dollar monitor, right? Dollar monitor is to print the values. Like in C language, however, we use the printf statement. In Verilog, we have dollar monitor, dollar display, dollar write, dollar strobe. There are different system tasks are there. Those things we will discuss in the coming session. So as of now, we are writing dollar monitor. So data is printing, select is printing, out is printing. So like that we can assign to the format specifiers. And data equal to 1010 initially at 0 simulation time. Select also a 2-bit binary 00, 5 at 0 simulation time, and next 5 time units, and next 5, and next 5. So every 5 time units we are changing the values. Okay, so that's why at transcript here 00011011. So based on that, output is generating. So for 00 output is 0, for 01 101 111. Okay, this is simple 4 by 1 mux. So if you want to generate 32 by 1 marks, what we need to do? Simply just remove 3 in place of 3 to 0, we can mention 31 down to 0, and number of selections must be 5, so 4 down to 0. So here also we can mention 31 down to 0, and here 4 down to 0. And you can write the data as a 32-bit input. So you need to mention like you can mention 32-bit decimal value as a what decimal value, 432156878. So each value will be 4 bits it will generate. Okay, and selection lines you need to mention uh, 5 selection lines, right? So 5 tick binary 0001. So it is somewhat difficult to generate all 32 number of selection lines. Okay, so without mentioning all 32 number of selection lines within the initial block, you can also write a always loop here. Okay, always block. How you can write always block? Suppose 32 number of selection lines means how it will be look like 0 0 0 0 1 0 0 0 0 1 1 0 1 1 1 double 0 1 0 1 double 1 0 triple 1. Next sorry, triple 1, and next 1 double 0. So the like the 32 combinations you need to generate. Okay, so without writing within the initial block, what you can do, you can take a always 5 always blocks. Okay, so here this signal is a S4, S3, S2, S1, S0. Everyone note down. So always hash any time, any simulation time. What is happening here? For every 5 time units, it is toggling. So 0 to 1. Suppose 5 time units you are taking 5 time units or 2 time units or 3 time units or 10 time units, whatever the delay. Okay. Suppose every 5 time units, it is changing to 0 1 1 to 0 0 to 1 0 to 1 1 to 0 0 to 1 1 to 0 0 to 1 1 to 0 for every 5 time units, right? So you can mention like always hash 5. Always is a repeating block here. Okay, always hash 5. What is the value here? S a 0. So always hash 5, S of 0 must be not S of 0, not S of 0. That means for every 5 time unit, this is how we will generate the clock. Okay, I will show you how to generate the clock in the Verilog HDL, because every sequential logic circuit we generate the clock, right? See how to generate the clock. Module clock generation. I'm taking a reg clock initial clock equal to, initially I'm setting clock as a 0 at initial time, and I'm writing always hash 5. That means for every 5 time units, always hash 5. That means every 5 time units, clock is equal to not clock. Okay, that means what? At 0 simulation time here, clock initially 0. Next 5 time units, clock is 1. Again, next 5 time units, clock is 0. Again, clock is 1. Like that. Okay. So, end module. Okay. These 3 things enough. We'll generate the dump to check the waveform. So initial begin. To open the dump, we need to write $dump fares. You no need to worry now. I will discuss later what is a $dump fares and $dump fares. And $dump file. Dump in the sense waveform. Okay, so here I already noted the point. Always block is a non repeated, it is a repeated loop until unless we stop the execution, it keep on running. Okay, so to terminate the loop, I'm just using $finish. I will show you what happens if we don't use $finish. Okay, so this is a simple logic. I'm generating the clock here. Okay, so just run. Okay, see here how the clock is generating 0, 1, 0, 1, 0, 1, 0, 1, like that. Initially it is 0, next 5 time units 1, and then 0, next 5 time units 1, and then 0, 1, 0, 1, 0, 1, like that. Okay, same here. For this logic, I just give you hint. By next session, you need to work on that and generate that. Okay. So always hash file S0 is equal to not S0. Okay. So if you observe these two, suppose at every 10 time units, initially 0, for next 10 time units it is 1, and next 10 time units 1 0, and next 10 time units 1, like that every 10 time units s1 is reverse complementing the value. Okay, so what you need to write here, always hash 10 time units s1 is equal to not s1, s of 1. Okay, so like this, by using always block we can generate s1. Next s2. For s2, if you observe, for every 20 time units, suppose here it is 5 means it is divided by it is into 2 and then into 2, right? So for 20 time units, initially it is a 0, and next 20 time units all are 1. Okay, next to 20 time units. Again, for next to 20 time minutes, all are 0. So what is happening here? Always hash 20 time units S2, S of 2 is complemented. S of 2 is complemented here. Okay. Like that, next S of 3, 20 into 2, 40. So for every 40 time units, S3 is complementing. Like that, every 80 time units, S4 is complementing. Okay, so that by using 3 statements, you can generate all 32 combinations, or you can use for loop, while do while loop, any loops we can use, but this is one logic. Okay, by using for loop we can generate easily within a single statement. Okay, by using always, this is one logic. So everyone try, and by next session submit it. Okay, is it clear everyone how to write the multiplexer code?
Ma'am, can you just explain the last one you just explained?
Which one here?
Yeah, this one. And the code for this too.
Code.
Yeah.
I told you to write from your side. Same here. However, I written for clock. Clock is a single bit variable here. Okay. So
I have this one question that you wrote this test bench, right? And without like writing code also we can generate writing bench or clock.
Without writing the code also we can generate the clock.
Yeah, like this is the first time I've seen that without even writing the code, we have just used TouchBench and we have run the code and we have generated the clock. Like,
We can generate that is we can do in a tool. We already installed the tools, right? A model simulator. There we can generate the clock without writing the test bench. But those all are manual. We need to keep on change for every change of the input. If there are 10 number of variables or 20 number of variables, it is very difficult to change manually, right? But if we write simple test bench, automatically we can generate all the stimulus.
okay.
Yeah, that's why we are writing the test benches. Manually we cannot generate for more scenarios. That's why. Okay, so coming to your doubt, here I have written only for one variable. Okay, like that you need to repeat for different. Suppose same logic, if I write same logic, I will write here for clock, suppose 4 down to 0. Okay, 4 down to 0. So please mute yourself. Clock of 0 is equal to not clock of 0. So every 10 time units clock is changing. Every 10 time units clock of 1 is equal to not clock of 1. Every 20 time units clock of 2 equal to not clock of 2. Every 40 time units every 80 time units clock of 4 equal to not clock of 4. Okay, so if you want to check more detailedly, you can write some statement also. Dollar monitor time also I'm mentioning. Dollar time clock equal to percentile. We can mention binary or okay. So I think you understood this logic. Same logic I have written there. See how it is generating. Initially clock is 0, then 1, 1 0, double 1, 1 double 0, 1 0 1, double 1 0, triple 1, 1 triple 0, 1 double 0 1, 1 0 1 0, 1 0 double 1, like that till 32 number of values it will generate. Okay, so I have written dollar monitor also. See 0 to 32 number of values. I think it is not generating 32 because here I use dollar finish at 200 only. Suppose if I mention 200, it will keep on running till 200. So if you observe here, still it is 00 1 only. So until all, okay, here all ones. Okay, so 2 times it is repeating. Okay, so see 0 to all ones. Total 32 number of combinations it is generating here by using only 5 always statements. Same code you can apply here for select. Okay, but if you want to write like this, you need to write 32 number of times select lines. Did you got my point now?
Yes,
Yes.
ma'am.
Okay, so that's why everyone complete till there. And next example is how to use the assign by using for the conditional operator. Before we have seen conditional operator, right? So go through that till here. So in the next session we will discuss on sequential logic circuits. Okay, so I will share you the assignment 1. Everyone, you can work on the assignment 1 and also complete till 32/1 multiplexer. Okay, clear everyone? Is there any doubts?
No, ma'am.
No.
Okay. Okay, then if you have any doubts, you can ping me and I will share you the recorded session also. You can go through the recorded session. Okay.
And Prashanti, so I have tried to install the Quartus Prime, so
Mm.
I'm unable to see the application. Can you please
Okay.
tell?
Can you share your screen?
Yeah, sure. So are you able to see my screen?
Yes, yes.
Okay. So I have tried this file and this Cyclone LP device support. So these two files I have downloaded.
2 files. Okay, can you go through that once?
Application, right?
Hmm. Not here in Google.
Okay.
Did I told only 2? Installation also you need to here Quartus Prime.
Yeah.
Did you
I
install
mean,
that setup?
so within these two, anyone can download, right?
Yeah, anyone you can download.
Yeah. So this one I have downloaded. So 802 MB.
Okay, okay,
And for device support, I have tried a Cyclone 10 LP device support.
okay. Next, go to the next. Go to next.
So already I think the installation has been done.
Okay. Better you can install Quartus Prime, not QuestaSim. Is that working fine? If it is not working, install this Quartus Prime.
This one,
Ah,
1.6.
ah,
Okay, maybe I will try.
okay.
But however, I tried so for these two
Okay.
files, but
Okay. Once
I
installation is
haven't.
completed, let me know.
Okay.
Okay. Others, do you have any doubts?
No, ma'am.
Okay. Have you installed the tools? Karar?
No, ma'am. I'll install it today.
Do you know how to install?
I'll try, ma'am. If there is any doubt, I'll let you know.
Okay. I will share you the recorded session how to install. Install Quartus
Okay, ma'am.
Prime model simulator. Okay.
Okay, ma'am.
Yeah. Okay then. Thank you all. If you have any doubts, please let me know in the WhatsApp. Okay.
Okay, ma'am. Thank you.
Thank you. Bye.
Thank you.
Bye.